Thank you to IRAS for its generous support of this series, and thank you to all of you for joining us. We have a fascinating question in front of us this evening. Are we beginning to pick up what we should call signals from other solar systems, other star systems? Perhaps. Are we beginning to are we beginning to wonder about the evolution of intelligent life, again, not in this solar system, but in other solar systems, perhaps not so far away? Are we picking up signals from our own evolutionary history that would lead us to wonder whether evolution, if it attains intelligence, also attains what could be called a moral and spiritual dimension? Not that human beings have attained a very high level, but is it built into the process? Intelligence includes a moral sense and a spiritual awareness. These are the questions that we're going to probe this evening, using not simply the latest findings from astronomy, but integrating those with questions. And Margaret Rappaport. Chris is a Jesuit priest and an astronomer with the Vatican Observatory Research Group, also associated with the astronomy department at the University of Arizona. He is a distinguished scientist, and that's evidenced by his memberships, honorary societies, the Royal Astronomical Society, the American Astronomical Society, the International Astronomical Union, and the membership, of course, in the Institute on Religion in an Age of Science, or IRAS. In fact, those of you who have hung around IRAS for a while will recall that nearly 2 decades ago, Chris served as the president of IRAS. The latest on Chris is that he has been honored in 2020 with the naming of an asteroid 119248, Corbally. So, Chris, your reputation extends far and wide indeed. You're being joined tonight by Margaret Boone Rappaport, a colleague, and together with you, co-founder of the Human Sentience Project. Margaret is a cultural anthropologist and biologist whose focus has been in neuroscience and in human cognitive evolution, resident in Arizona, but having spent many years in the eastern part of the United States in government service and in other roles. So we're going to turn to this team of Rappaport and Corbally, and they're going to be presenting for 35 or 40 minutes, and then we will have a response offered by Jennifer Wiseman, who will be introduced a little bit more later. Following that response, perhaps a little dialogue between the presenters, but then as quickly as we can, we will open up the webinar for participation from the wider audience. What you do is use the Q&A function that is in the bottom of your screen. If you draw your eyes down to the bottom of the Zoom screen, you will see Q&A. Simply open that link, type your question, and I will field those questions. And just a simple hint, I look for questions, not for elaborate comments, and succinct, precise. And if you post something, you can be pretty sure that your question will be part of the webinar here tonight. So with that orientation to what we're doing this evening, let me now turn the webinar over to the team of Margaret Rappaport and Chris Corbally.
Am I on?
Yes, Margaret, you are on, so please go right
Didn't want
ahead.
to start before I knew. Okay, thanks, Ron, very much for that lovely introduction. Good afternoon, ladies and gentlemen, or it may be evening where you are. We're not certain. We're all in different places. I want to give a quick introduction to our problem and then the logic that we'll be using with our two disciplines to approach that problem. Next slide. First, I have to thank somebody. Actually, several people. I need to thank the Reverend Dr. Ted Peters, because he was instrumental in allowing us to use the chapter that we wrote and that appears in astrobiology. And in particular, the figure, the table that you'll see later in the presentation. So thank you very much, Ted, for giving us permission to do that. The chapter is titled Interstellar Ethics and the Goldilocks Evolutionary Sequence. We borrowed Goldilocks there. Can we expect ETI to be moral? I want to point out that we had a third author, and that's Conrad Sozik, and you'll see his name on the screen there. So Conrad is also with us in this publication. Okay, Chris.
Thank you, Margaret.
Hold on, that was just the next slide.
Yes, exactly. So that, yeah.
Chris and I have not seen each other in about 10 months, but we are at two different ends of Tucson, Arizona right now. We talk to each other like we're together. Okay, quick introduction. There is a problem, and that is that we don't know whether ETIs exist, extraterrestrial intelligences. We don't have any firm proof that they do, and it would be even harder to have firm proof that they don't. So we are approaching that problem from two different directions. And the goal of our chapter was to begin the development of a vetting process to try to determine whether an interstellar species that lands here on Earth, whether they have a sense of right and wrong, an ethics, an ability to determine appropriate versus inappropriate behavior. So the protocol, the vetting protocol, was in fact our original goal. That idea came, I have to tell you this, from a dinner party that Chris and my husband and I went to, where we met the gentleman who had, when he was with government, the role of telling the president their firm evidence of an extraterrestrial intelligence was available. Of course, he never did that, but these protocols exist. I'm sure they change over time and with administrations, but that's where the idea of the chapter came from. So we asked, will we be able to communicate with them? Does the species have a neurology that distinguishes right and wrong? Human beings actually have a mechanism that is used to assess anything and everything as to whether it's ethical or not ethical, right or wrong. Okay, so that's where we're going. Chris comes at that from astronomy. He comes at it from instrumentation and signals of certain kinds, and he'll tell us how far those signals can get us right now, which is not as far as they will in the future, to tell us whether there are living species elsewhere. Then I'm going to come back on and go through that table, which is really an evolutionary sequence that takes us to the reward, which is ethical thinking, moral thinking in Homo sapiens. Now then, the question that will remain at the end of this evening is, will the ETI have religious thinking? And that is another presentation. So with that drum roll, I will turn it over to my colleague, co-author, and business partner too, Chris Corbally, and I think you'll enjoy. Now then, he told me to take out this little note in his slides that said, watch for the movement, because he thought that was sophomoric. But I will tell you, watch for the movement in the slides, and you'll see some things that you've heard about, but never had illustrated quite so nicely. So it's over to Chris now, and then it'll come back to me real quick. Christopher.
Lovely. Thank you, Margaret. So as Margaret says, watch for the movie, or we've had with cameras, watch the birdie. So there's going to be one or two things that move. But so how do we, from astronomy, detect possible life out there? Both within our solar system, which is a problem, as you well know, and then beyond, in planets around other stars that we call exoplanets. I did my graduate work in astronomy, a PhD in Toronto, and a fellow grad student there was Bruce Campbell. And he, after graduating, went on to try and find, refine the technique for finding planets beyond our own, around other stars. He, in the end, didn't get quite precise enough. Who did were these two in 1995. So Michel Mayor and Didier Queloz, whom I'm sure you've heard, they did have success with that star called 51 Pegasi. And basically they found that it wobbled. Ooh, so what does that mean? So we have the star in the center, and we have the little planet going around it. This planet doesn't go round the center of the star. Instead, they both go around that balance point between the two, which is inside the star because the star is so massive. And it's that sort of gravitational center point that the star itself is going around, and bright enough if we can look at its light precisely enough to see changes. Maybe you can think of yourself as looking from the bottom rather than at the top, as we're doing it, from right the top of the star. Look from the bottom of the screen and see what it looks like. And you see the star moving away from you and now towards you, away from you and towards you. When you look at the spectrum of the star, you can actually see that the spectrum gets redder as it goes away from you, gets bluer as it comes towards you. So there's that change from red as it goes away to blue, and that's called the Doppler effect. I'm sure most of you know and have seen that, the old train whistle, train coming towards you, and it's high pitched, and as soon as it passes you, the pitch drops. That's the same wave phenomena called the Doppler effect. What this finds is the larger planets close to their own stars or their own suns. These larger ones are, Jupiter and more size, several times the size of Jupiter. So probably not the great places to look for life, in our solar system or stars, planetary systems beyond exoplanets. So good as this is, an even better method came for finding Earth-like planets. In the Kepler Space Telescope, which went up in 2009. And that went up and its camera stared at a single patch in the sky. If you hold your hand out, the palm of it out at arm's length and up in the sky, it's about that size of a patch of the sky. It looked at some 150,000 stars and seeing whether there was a tiny change in the brightness. Why was it doing that? And so watch the birdie here very closely, because what you should see just beginning to come into the star is a little black dot, or in this cartoon, a planet crossing the surface of the star. And its brightness is shown in the plot below, and it takes several hours to do so. So be patient, and eventually it'll move to the limb and then out and the star will resume its brightness. It's very tiny, but that telescope up in space was able to see these tiny variations. Maybe we can just do it again. So we're seeing what this does find for us are the planets that are much more like the mass of our own Earth. So that's great. We're getting on towards, and it's there that we think there'll be possibility of life beyond our own solar system. So and very successfully what the Kepler Space Telescope in its lifetime detected 2,662 planets. So a really wonderful 9.5 years of service. But how do we tell whether there's actual, first of all, what will be a great advantage to knowing that there could be life around these stars, the ones close by, the Earth-like ones? That's if they are in what's called colloquially the Goldilocks zone, or the just right zone, just right for temperature, also called the habitable zone. It's in the habitable zone, water on the surface of a planet will be liquid. And we believe that that's important for life, though obviously there are extremophiles on Earth that love living in extreme spots. But on the whole, we've done awfully well with liquid water on our planet to produce life. So one thing about it, this is typically for a star pictorially rather like our sun, and it's got a fairly large habitable zone, that green zone there. Where the temperature is just right for liquid water. But in this kind of game, our sun is fairly rare, relatively rare. There are a lot more of the lower mass stars, and in my classification scheme, what I'd call the M stars. But then the habitable zone narrows extraordinarily and gets very close to the planet, to its sun, such that the face of a planet always stays pointed towards the sun. So we know that that happens with Mercury because it's so close to our own sun. So one face always gets the sunlight and the other never does. Would that be great for planet? Maybe not. But anyway, that's what we've got to deal with. But that's the Goldilocks zone, which a term we'll use later. Okay, but still having found planets in the Goldilocks zone, how do we know that there might be actually life on those planets? And a way to do that is, various ideas. One, you listen, and that's the whole thing of the search for extraterrestrial life, extraterrestrial intelligence, the SETI Institute. You listen and see if you can hear radio signals. And it probably won't be "Hello Earth, it's us, ET," but there'll be something that's intelligible, something that's not from just from as it were pure nature. There's an intelligence behind a signal, and we think we might be able to detect that. There are other ways as well, which the SETI Institute and Jill Tarter has talked to us on IRAS on Star Island a number of years ago. And she would say, look for some sign of high energy engineering going on that gives us a special radiation from that particular star, that direction in space. Well, okay, maybe so. Dyson Spheres is something that you could probably know about, if not go and see. And one of the Kepler stars was thought to have a Dyson sphere around it. It was so peculiar. I think not. So no luck yet on that. But there's also other ways through spectroscopy, and with large telescope and delicate instrumentation on telescopes on Earth, we can actually detect atmospheres of planets as they are in transit by as you were subtracting what you see from its star, its sun on its own, and then the difference when a planet is going across, particularly critical right at the edge as it exits its transit. So yeah, again, these techniques are needing to be refined, but there's a chance of detecting oxygen and methane. And if methane persists in the presence of oxygen, there's a very good chance that methane is being produced by life form of some kind, even decaying vegetation. It doesn't have to be cows. But there's also another way as well, and that's through something we're familiar with, photosynthesis. So here's a picture of the green leaf, highly magnified, light coming in from the top and the top surface of the nice healthy leaf, and light is coming in all the colors, as it were. If I can see, so there we have all the colors of light coming in. You'll notice that the top layer up here absorbs the blue and the red, letting the green reflect back, and that's why the leaf looks green. There's also this white, or the radiation, as infrared radiation that comes in further and also gets reflected out. Now, if we can get our spectrograph looking at that light coming out from the leaf, what we will see, and here in this plot is reflectance, or the energy, the intensity of the energy being reflected against wavelength, blue on the left and red and infrared on the right. The chlorophyll in the leaf, that what we're seeing there, will that top upper surface there, absorbs the blue and the red, letting go the green. So what we'll see is a gap there in the spectrum due to that absorption. And then we'll see a big transmission of the red and the green, the infrared and the green coming out. And that's this bump on the other side of that big dip on the left. And so the whole kind of steep edge is called the red edge. That's a sufficiently large kind of feature for our spectrographs on the big telescope on Earth to be able to detect. So if you hear about red edge, you know what it is. It's there, something we can see and observe on Earth, and maybe we can observe it in the atmosphere of, or at least in the signal from an extrasolar planet. Wow. Life then, if there's a red edge, is it intelligent? Yeah, that's the big question. And I suppose that's what we're now going to go on and try and answer when we can get, as it were, a real interaction with whatever it might be out there. So, Margaret, how about taking it on?
Okay. Thanks, Chris. We have only one example of an intelligent species on Earth of the type that humans represent, and that's us. We don't have another example that can help us try to predict what ETIs will be like, or whether they will be moral thinkers. So what we decided to do was to take an evolutionary sequence that we had developed for another purpose altogether, and see what that sequence suggested about the things to look for in an ETI. If an ETI lands, what do? And the first question is, of course, do you have time to do anything? But if you do have time to do anything, then what do you look for in that species? And how do you deduce from all that you see that they are thinking morally, or that they have a differentiation of correct and incorrect behavior? The whole reason humans have ethics is to create reliable social behavior, to encourage it. So we can try to find that in the ETIs if we can communicate with them. So what are the characteristics to look for? Let's go on to the slide that follows. Okay, this is the table that we got permission to use, and it's displayed in 4 slides because otherwise you wouldn't be able to see it on your screen. Sociality began a long time ago, about 65 million years ago, with the first primates. The sociality that is part of human biology and psychology, that kind of sociology or sociality. So we're going to look for social life. And indeed, it is quite logical that if an ETI lands on Earth, that they are both technologically and socially sophisticated. Otherwise, they would not have been able to construct the spaceships. I mean, large constructions, that's part of Jill Tarter's logic too. Large constructions take a lot of cooperation. Think about the lines of the materials that go into building a space station or a spaceship. They're from all over the world. Okay, so this is going to go from 65 million years ago, lickety-split, right up to where we are today. And I'm going to mention them in evolutionary order. So the sooner I mention them, the sooner the longer ago that they happened. The next one we thought was very, very interesting, and the work on this has only come out since about 2018. There were excellent articles out of Japan and out of, I think, it was either England or the US, I don't know, about the lateral medium cerebellum. And it developed especially greatly in the anthropoid apes. There was parallel evolution. So the lateral medial cerebellum also developed quite a bit in 2 other orders, and that is the cetaceans and the pinnipeds. The cetaceans being the sea mammals and the pinnipeds being seals. So in those 3 orders, the cerebellum does what is called the quality control of the brain. And it does the quality control in the human brain. So it enables, if you look at this very new literature, intelligence and innovation, creativity. Okay, social life, capacity for intelligent behavior, capacity for innovation. Can our ETIs innovate solutions to problems? Human beings are social group problem solvers. So are our ETIs social group problem solvers? Next, basic ape model. We came from the anthropoid apes. The first true ape arose about 19 million years ago. The thing about apes is they're in many ways very generalized, but they're big. They have a big body and have a big brain. So the brain that had got so big for us started getting big in the anthropoid apes. So is there evidence that the ETI, has a very substantial intelligence? We would certainly expect it. The other thing about apes is true of humans too, that they're behaviorally demonstrative at times. Mm-hmm. Okay, well, a lot of things happen in certain groups of late Miocene apes. There was a realignment of the senses. And we fastened on this because senses are so important in religious capacity and religious behavior and experience. The experience of the Mass, Haitian voodoo, Buddhist prayer flags. There's beauty. We are moved by these things. So our goal was religion. And remember, we're going to stop short of religion when we talk about ETIs. So we have really good vision and hearing. Next slide, please. There was a lengthening developmental trajectory. It lengthened at the beginning to create youth. It lengthened at the end to create old folks, older people, experts. And those two things became very, very important in advanced neurocognitive traits and passing them on to the next generation. I'm going to speed up a little bit. There was a downregulation of aggression in some groups of late Miocene apes, we believe, but there was also a downregulation of aggression all the way up to when modern Homo sapiens appears. So that was a long time. The other thing about this whole series of innovations is that they all happened at the same time and they encouraged each other. So it was a system that was evolving. It wasn't just this characteristic, this innovation, it was all together. So it resulted in what I've called the modified domestication complex. The really interesting thing about human beings to me is that the aggression was reduced, but it's still there. And the thing that controls it is our intelligence. We know when to turn it on and when to turn it off. We can go hunting for food to feed our family still, if we have to. We can fight off a robber if we have to. So that aggression is still there. So we didn't get domesticated completely. Upgrades in intellect, tendency for large brains. Okay, that started long ago. Next slide, please. Very genetically based sensitivities. This is really important for the thing that we were aiming for, which was religious capacity. There are different kinds of sensitivities and they're pegged to different genes. There are sensitivities to people in the in-group and there's sensitivities to people who are not in our in-group. There's sensitivities that engage the emotions, and there's sensitivities that don't engage the emotions at all and are simply make us ready for action. We're alert, we're ready to move. So they varied and they emerged in our early ancestors. And so do we find these in ETIs? Are they sensitive to differences among us? Biological foundations for culture. Again, I think probably came late, about 8 or 10 million years ago. Culture is the assignment of meaning to arbitrary objects, ideas, people. So there's the arbitrariness to culture that is imbued into religious capacity. Again, that's what we were going for in our book. We don't think ETIs will necessarily be religious. Okay, then beginning about 2.8 million years ago, Homo habilis appeared, the first species in our genus. And there are those who, well-respected anthropologists who believe that Homo habilis was a part-time aggressive scavenger of meat, and that Homo habilis's brain was already enlarging even at that time, and the brain could not have been fed unless a Homo habilis could get some meat. The brain uses far more energy than any other organ in our body. So the brain got bigger, we ate more meat, exaptation of neural networks continued. That is, one neural network evolved for this thing, well, it was taken over by the next species on our line for another function. Okay, next slide, please. Okay, so about 1 to 1.5 million years ago, our model says that Homo erectus had some form of moral adjudication. In other words, some nascent ability to distinguish right from wrong behavior. And we place that at our first full-time ground terrestrial Homo around something that we call the human hearth. In other words, after everybody's come back from gathering and hunting, you know, there's going to be some comments in whatever rudimentary language was evolving about who did well in the hunt and who didn't do well in the hunt. who let the group down, who didn't leave the group down. I mean, that is the core of moral adjudication, is decision-making about who holds the group up and who lets it down. So evaluation of everything from good to bad, and we still do this for everything. We evaluate ourselves, we evaluate our thoughts, we evaluate our actions, we evaluate other people's. We're making good and bad decisions all the time. It's not just something we do in college classes. So we think ETIs will evidence some indication of all the things up to this point. And we have a little question and answer we do between ourselves to kind of vet an ETI. Now then, the big question mark is religious capacity. And so let's leave that for another time. We see it coming in pretty solid, probably about 20,000 years ago, 120,000 years ago. Chris, what's the next slide? Okay. We did a case study in the chapter on arrival. And we looked at whether we could apply what we learned from that sequence we just went through to the heptapods, these big creatures from another star system. And we concluded they were moral thinkers. We concluded they knew a difference between right and wrong. Do we want to do this, Christopher, or not?
Yeah.
Yep.
5 minutes. Yep.
Let me find it. Okay, got it. All right, and I'll ask the question and you give the answer. Okay, what this is just kind of a mock version of a vetting protocol. You would have to, oh, I forgot to mention one thing about the picture. Remember, that was important. Yeah. There are 3 specialists in this picture, and they're very, very important. One is the girl who's a linguist, the man is a physicist, and the fellow right here is with the military. So that is all to say that there is an aspect of risk in not being prepared for a visit from another star system. It may happen next year, it may happen 1,000 years from now. We have no idea. But there's risk. Okay, first question, there's 4 questions. And Chris is gonna vet the heptapods. Okay, question. How do the Americans know the ETIs are not initially hostile?
Okay, that's easy, Margaret. They haven't started shooting at us.
They haven't started shooting, okay. Second question. How do they know the ETIs have culture or something like it?
Oh, okay. If you've obviously seen the movie, you'll know what we're talking about. And if not, well, why not try and get it and see it? I think you'll find fun. So, how do they know the ETIs have culture? Well, one, the arbitrariness of their written language. Remember, Margaret emphasized the arbitrariness of culture. And that language is displayed for the humans on a translucent screen between the humans and the heptapods. The cursive is circular in form with patterns of figures that repeat and represent different concepts and items as the linguist discovers. She catalogs this on a handheld screen and eventually in a book. It's a true language of recombinable units of meaning or morphemes. Okay, you convinced, Margaret?
I'm convinced. I mean, I was convinced when I saw the movie. Question number 3. How do you know that the ETIs have morality?
Oh, this is the
hard.
$10,000 question. Well, after several exchanges between the linguist and the heptapods, a rogue military person, so not our fellow in that picture, but a rogue military person, plants a bomb on the starship. The heptapods forcefully eject the humans just before the bomb detonates, so saving the humans. Now, the explosion results in the injury and death of one of the heptapods. So they save the humans and sacrifice themselves, demonstrating a respect for life, as well as an acknowledgement of the importance of their mission. So there were values, they were following values there. Okay.
Well, they saved the humans at the sacrifice of one of the heptapods, who died.
Yeah.
Question number 4. How do you know the ETIs are social?
Complex, there are 4 answers to that one. So just briefly, they're social because they open the door to their vessel regularly every 18 hours. That's an invitation to come in and interact. 2, they continue communicating with the humans through their written language, which the linguist is learning. So they're continuing that relationship which they've invited. 3, when the linguist goes by herself to converse with them, they allow her to come up alone and provide transport for her to do so. And then finally, which is quite a long one, but just briefly, we later learned that the purpose of the visit of the 12 ships, and that is more broadly social. Okay. I'm not sure we want to give away the whole of the movie.
No, don't give away the movie. That would be, it's a good movie. Okay, I think, what's the next slide?
The next slide is, there we go.
Oh, there we go. Well, we plugged Ted's book, so we got to plug our book. We just published The Emergence of Religion and Human Evolution, 2020 from Routledge in Great Britain. And the entire scientific bolstering of that table is in that book. Also, if you want a copy of the table, just send me an email. And I think that with that, we are going to end. I don't think we were as brief as we were in practice yesterday, but we're going to give plenty of time for our discussion, and we're really, really honored, Ron, I think you're going to take it, to have Jennifer Wiseman comment on us. And thank you both to go ahead, please.
Well, thank you. We've been listening to the team of Margaret, Boone, Rappaport, and Chris Corbally, reflecting on a fascinating question of what can we possibly know about the existence of intelligent life elsewhere in the universe, and if it does exist, what might we reasonably infer about its capacity, not just for intelligence, but for spirituality and morality. We go next to a response from if you don't know about that program, you definitely want to learn more about it. Jennifer works with the AAAS program, but the larger part of her time is spent as an astrophysicist with NASA, where she directs she's a senior project scientist, I should say, for the Hubble Space Telescope. She has vast experience in the search for extra solar exoplanets, as we have come to call them, exoplanets, planets outside our solar system, where it might be possible that intelligent life exists. I should, earlier I said that Chris Corbally has an asteroid named for him. Dr. Wiseman, based on her work as a graduate student, led to the discovery of a comet that bears her name, the Wiseman Skiff comment. So, folks, we really have an extraordinary, I'm tempted to say star-studded cast here tonight, but at least a heavenly cast, if not stars, at least asteroids and comets. But with that, let me go to my good friend, Jennifer Wiseman, who's going to respond. Jennifer, go ahead, take it away.
Okay, thank you very much, Ron. And today I'm just kind of speculating from some of my own personal perspectives, not the organizations I represent, but you did cut out there a minute, at least for me. So I wanted to reiterate that the audience might be interested in checking out the program of dialogue on science, ethics, and religion, or DOSER program of the American Association for the Advancement of Science, the AAAS, where we bring scientific communities, religious communities, and ethicists together to talk about interesting questions like the one we're contemplating tonight, about, you know, what would be perhaps the characteristics of extraterrestrial life. And I'm so grateful to you, Chris and Margaret, for your outstanding presentation. I got to do a sneak peek of the chapter in the book that they discussed, and it's just so well worth reading. So I hope when this book comes out that all of you in the audience will get it and read it. So let me just make a few comments here. There's actually been a lot of speculation about extraterrestrial life for a lot longer than I imagined. I started looking into this a few years ago because I was giving a talk on the kind of theological implications potentially of finding life. And I thought, well, maybe people, I'm certain over the last century, have been thinking about this a bit. Well, I found out it's been, you know, well over a millennia people have been thinking about this, and I don't even know why. We didn't even know that, understand star systems the way we do now, but people have been speculating about extraterrestrial life for millennia, and even deep theological speculation about the moral nature of extraterrestrial life has been written down many, many centuries ago. It's a fascinating topic to study. And then, of course, more recently, with the advent of science fiction, we're all exposed to science fiction as being a wonderful setting, using the setting of space and interactions with alien life as the kind of backdrop for contemplating deep moral issues that humans encounter. And so this imagination of extraterrestrial beings and even the contemplation of their character has been going on for quite some time and has far outrun the science. But now, and by now, I just mean this incredible period we're living in right now, the last few decades, is a very incredible, unusual time for humanity, because within these last few decades, we've gone from knowing for sure of no planets or orbiting stars other than our sun. I mean, we didn't know if there were any planets orbiting stars other than our sun, to the point, as we've heard from Chris, that we've detected now thousands of these planets orbiting other stars outside of our solar system. Right now, I just checked the NASA exoplanets website. You can too, exoplanets.nasa.gov, I think. There's over 4,000 confirmed exoplanets now, and over 3,000 systems that often have multiple planets. Now, the fact that we can even say this is quite amazing. It's because the technology and the techniques have become so much improved and so much sophisticated over the last few decades. We often have to use, as you heard from Chris, indirect detective techniques to detect these exoplanets. And what's happening right now is the quick maturing of telescopes and techniques and technologies for studying these exoplanets and for analyzing their atmospheres, the atmospheric makeup of these exoplanets, because it's really studying their atmospheric composition and nature is the only way that we can really detect evidence for potential biological activity on these exoplanets. We look for something called biosignatures in the spectra of these exoplanet atmospheres, because we as humans can't realistically travel, unfortunately, to these other star systems ourselves. So we're mostly astronomers right now in federally funded science are mostly not looking for signs and signals intentionally sent from advanced civilizations, although there are private organizations like SETI that are doing this. But most astronomers are rather looking for the potential habitability of exoplanets, even the habitability for very simple life, maybe single-celled life. And if you think about it, life on Earth, our planet, has existed for most of the time of Earth's existence, for billions of years, which is incredible. Life started early. But most of that time, for billions of years, it was very simple life before it started to advance into the kind of advanced life forms we know now. So one could conclude that the most likely life existing on other planets would be, that we might detect, might be more likely simple, like monocellular life. Now, it's hard to describe how huge of a change of focus this has been in the scientific community, in particular in professional astronomy and astrophysics. Now, when I was a graduate student back in the 1990s, this birth of searching and finding exoplanets was seen as kind of a fringe part of professional astronomy. Sometimes it was given the rather unflattering name of bean counting rather than true astronomy. But with the explosion of discoveries of exoplanets, and also I will add more sophisticated studies of planets and moons in our own solar system, looking for potential habitability, the study of exo-Earth life has transformed into one of NASA's primary focal points. And the same is true for other nations' space agencies and research. And even a new science called astrobiology has popped up that combines astronomy, physics, geology, biology, planetary science, and chemistry to understand the habitability of extreme places on our own planet and potentially in other places across the galaxy. So there's been a huge change in the centrality of this kind of study in mainstream science. And what all of this has done, and I must reiterate, we have not yet found any life beyond planet Earth, but we now know of so many places where life could potentially exist that it has re-energized all the contemplation of what it would mean if we do find life, even simple life that exists and maybe even started independently of life on Earth. So it's rejuvenated not only this type of science, but also the things that the other types of contemplation that build on science, whether it's philosophy, theology, these kinds of things. So even though the focus right now is on habitability, it does re-energize this contemplation also of the possibility of interactions with advanced life. So while the immense distances of space kind of make two-way communication with humans from our distance from other star systems very slow and somewhat unsatisfying from our point of view, there is always, and I've also already mentioned that right now we don't as humans have the technology and the ability to travel to other star systems in a meaningful, realistic way physically. But what if the aliens could visit us? And so all of these scientific discoveries have re-energized the contemplation of what that would mean. And Margaret has explained the kinds of characteristics that they recommend we look for, that might indicate that the species that we interact with, that has come to us, might have a sense of moral values. And the key to this, as I have heard their talks, would be sociality, social life. It does seem logical that extraterrestrial intelligent beings would have had to have some kind of social sophistication in order to develop the technology and plans to make such a trip. And as Margaret described in the model that she and Chris and their collaborators have developed, social sophistication evolves. And she described how this has happened in human social evolution. So I have a couple of more quick points and then a couple of questions for our speakers. I do wonder if we encountered advanced life, and if they in fact had admirable moral character, and they might not actually intend to harm us, but couldn't they perhaps unintentionally harm us by transferring viruses and things like that that we are not capable of defending ourselves from? I also wanted to bring up the point, since this is a symposium or an organization looking at religion in an age of science, that much of the philosophical speculation that I hear on what it would mean if humans encounter extraterrestrial intelligent life is on whether these beings are to be feared, and whether encountering them will completely transform our understanding of ourselves as humans. Now, I think certainly the latter will be true to some extent. But I also keep in mind myself that people of many faith traditions on planet Earth already embrace the idea that there could be and perhaps should be life beyond Earth. And I think Ted Peters, theologian, has written much on this topic. For people, for example, of Abrahamic faith traditions, there is no sense that an alien species would somehow be a surprise to God. In fact, the God who's the author of creation would be fully aware and even responsible for the existence of life throughout the universe if it exists. And furthermore, meeting alien life would give reason, or should give reason, even for further praise and awe of the God that human believers already know. So there's the question of whether the alien beings have religion and morality, but then there's also the question of people on planet Earth who profess a religious faith. How does that transform the way they view the prospect of seeing alien life? And for Christians, I would posit that the Redeemer, known in human form as Jesus Christ, is indeed the author and loving Savior for all of the cosmos. In fact, that's a central point of the incarnation, so that people of faith can in fact pray and ask God for wisdom if we come to the point of actually interacting with extraterrestrial intelligence. God is not surprised by the existence of these extraterrestrial life forms, and in fact is glorified. And I'm reminded of James in the New Testament, James chapter 1 verse 5, that says, if any of you lacks wisdom, you should ask God, who gives generously to all without finding fault, and it will be given to you. So praying for wisdom is something that that believers on planet Earth can do if we ever have this potential encounter with alien life, and without necessarily a sense of overwhelming fear. In fact, even evangelist Billy Graham was quoted as saying that he fully expects there's life throughout the universe, and that they are not to be feared. They are also creations of God. So with that, I have 2 or 3 questions for our speaker, Margaret and Chris. One is, what about the fact that other species on Earth also show social structure and compassion and grief, even like elephants and dolphins and advanced primates? Would you consider them to be moral? And recognizing that is the way that we interact with these other species, alien to us in a sense, that are already on planet Earth, do they tell us something about how we may interact for better or worse with alien intelligent life forms from other planetary systems that we may encounter?
Do you want us to respond yet?
Yeah, that's
now,
question
or?
number 1, and then I have one more after that. Yes.
Oh, okay. There is a philosopher, his name is Persson, Persson, and he made an observation that if an extraterrestrial intelligence comes here, they may be just as interested in whether we're moral as we're interested in whether they're moral. In other words, are they going to see how we treat each other and how we treat other species and evaluate that? I think it was an awfully good point, and it is in our chapter, thanks to this gentleman. As for whether, well, Chris, why don't you take the other one? Whether other species that show social structure, what does that say?
Well, I'm not sure. I think that's more yours. You've spoken, Margaret, about
We're
ants.
trying to get rid of the question.
And bounce back, I do, because ants show social structure and the wonderful ant hills that they can build. But
Well, we have had this discussion a lot, and there are different kinds of sociality, clearly. I mean, there's more hardwired sociality in ants and bees, and a lot of it is regulated by hormones we're figuring out and whatnot. When you get into the mammals, you know, the very nature of mammalian reproduction and nurturance of the young encourages a beneficence between individuals, I think. So all mammals, most mammals to me, behave towards each other in a beneficent way, help each other in certain kinds of ways, help feed each other and all that kind of stuff. When you get into the neuroscience of this stuff, you start seeing how extraordinarily different human beings are. Not any news, because every species is different in its own way. It has its own special things. So, you know, Chris and I have developed ways of dealing with this question, especially like our near relatives, the chimpanzees. I mean, you know, they're actually not as close as a lot of species have been. You know, we've had other species that are extinct now that are much, much closer. But do they have moral thinking? And we have concluded not, based on criteria, not just sociality, but agency, intentionality, self-consciousness, consciousness of others, and theory of mind of the others, a timeline, and a neurological decision-making process. He's trying to stop me. Okay, I'll stop. And that's it. I told him if we got into this question, Chris, stop me. Okay.
It's a big question. We've got a number of
yeah, we got a lot of questions. So,
Okay.
so the answer is we're alone in our moral decision making.
In our papers,
that is our conclusion.
We've considered compassion.
We're the only ones who can really do it.
And found that compassion, while has its emotional, aspect, is primarily an intellectual thing. So we need minds, well-developed minds to show compassion, to have and to show it.
Yeah.
Can I mention Glimcher, and then I'll leave that question. Okay. There is a neuroscientist named Glimcher, and he very carefully talks about how the decision between a right and wrong happens electrically, actually, in our brains, and it's quite a good paper. That's
okay.
it. Sorry, that's an evening.
Yes, I thank you both for that. It's a hard question, and
Yes.
I also wonder, and you don't need to answer this, but let's say that the aliens are moral and they are not hostile, they only want our good. If they are advanced enough to understand that they might actually carry a virus with them that we could not tolerate, wouldn't they just not come? Wouldn't that be the most moral thing to do, is to not interact with us because of that risk? So that's just food for thought there. I have another question that I'd like to ask, but I think I'm going to hold that off till later if Ron will call upon me sometime later, because it's a more of an overarching question that might be good to end up with. So with that, why don't I turn it back over to Ron and let him orchestrate some questions from the audience. Does that make sense, Ron?
That does. And thank you so much,
Yes,
Jennifer. So yes, the questions are beginning to come in. I think we're up to past 10 of them at this point. The first question is a very obvious one. The universe is huge, Jason writes. Why haven't we heard from anybody yet? Or an anonymous attendee writes, so where is everybody? Now, I suppose part of the answer is embedded in Jason's question. The universe is huge, but if there are a lot of habitable planets out there that could possibly host life, have any of them, I mean, what's the probability here? Have any of them attained intelligent life that produces the kind of electromagnetic signaling that the planet Earth has been producing? And if so, why aren't we picking that up? Let me direct that first to Chris, and then we'll just see where that goes.
Hey, well, thanks, Ron, and thanks, Jason, too. There are books about this, and there's a recent one as well, the Fermi Paradox, so you can look that up, and we can't possibly answer that at the moment. Yes, the distances are huge, that's one factor, but, are we living in a rare Earth, so the possibilities of actual intelligent life like us, Homo sapiens species developing, others extremely small chance, etc. So it's been well discussed there. I think you're asking me, do I think that SETI, the Search for Extraterrestrial Intelligence, is worthwhile? And my short answer is yes, I do. Margaret?
I think that there's no good evidence either way. And what the question devolves to is, what do you believe? I actually think there are aliens already that have located us. I think that we're in an adolescent stage for our species, and they're holding off. That's what I think. So.
All right.
Ron?
All right. Well, thank you. So let me pose a pair of questions that kind of get at the some of the theological assumptions here from two different angles. One reader, one member of the audience observes, John writes, is the religion in IRAS, or specifically this webinar, only of the Christian variety? And in terms of IRAS, of course, the answer is no, but we've been decidedly Christian here tonight. Would it be possible, John continues, for sophisticated ETs to be, let's say, more Buddhist in their approach than they are Christian? But let me pair that with another question that will take you in a different direction. And Jennifer, we might bring you back in at this point, because you did introduce very specific theological themes that are more characteristic of Christianity than, let's say, other traditions. So Craig writes, do you think that every created life bearing order may be Christologically structured? In other words, is that the takeaway message of the first chapter of John? The order or the logos of the universe is Christological. Do they bear a word character that transforms them from within? I'm not quite sure how to interpret that latter part. But what I want to do here, Margaret and Chris and Jennifer as well, is just put out a kind of a tug of war that might be going on in the minds of a lot of us who are listening to this. Does this kind of reflection lead us to any kind of theological conclusions one way or another? Or does it inspire us to imagine that we might learn a whole new level of intelligent theology if we are in fact visited by some alien species that has somehow managed to achieve a level of sophistication technologically far greater than ours, and at the same time managed to survive and cooperate with that advanced technology? Are we sort of stuck here on planet Earth? And could we learn something completely new that breaks through the traditions that have shaped the religious terrain of the of humanity in the past few thousand years? So I'm not sure where we want to start with that. Chris, you might want to jump in, but Jennifer, I'd appreciate your comment as well. But Margaret, perhaps, who'd like to begin?
Well, I'm an anthropologist, so we didn't write a book, The Emergence of Religion and Human Evolution, for just Christian thought. I mean, I'm a Presbyterian, and there are not very many Presbyterians, relatively speaking. But anyway, so everything that we have to say about religious expression and operation and achievement pertains to every single religious system that I've ever studied. I think the idea of learning a new way of thinking, a new intelligence, a new theology, if you want, from an ETI is a great idea. I mean, and there is every reason to believe that there are different types of intelligence. Now, then, if you look at that sequence in that chart, it's systemic, it's tight, they encourage each other. So there seems to be a teleological nature, is that right? Not theological, teleological nature to it. It seems to have a nature that goes, well, if we have a different biology and if we have a different chemistry, let me just give you a simple example. There are worms on Earth where the central part of the porphyrin ring has a different molecule or a different molecule in the middle. And some of those worms have green blood, other worms have red blood. So there's a lot of different things that can happen in the course of evolution where chemical species can substitute for each other. But I got to tell you, I don't think this happens very often. I mean, the more you get into the details of that table, it depended so much on chance. I just don't think there are a lot of them out there. So let me turn it over to Jennifer or Chris after that.
How about Jennifer? Yeah. Having disclaimed our thing about any particular religion, and certainly our book would have been better titled, though it was longer, The Emergence of Capacity for Religion. Rather than...
They'd have never titled it that. These publishers change your titles on your books.
So we're not opting
they always do right at the end.
We'll wait and see what ET's religion is. Be fascinating.
I think
ETI religion.
Yeah, what I tried to mention, I mean, I'm no expert on this, but is that there seems to be a very very deep societal expectation, at least in popular culture, that if and when we encounter alien life, it's going to have a huge transformation of our worldviews, whatever those worldviews are based on. And yet, as some of the research of Ted Peters has done, when you actually talk to people from a variety of religions, from a variety of faith traditions, all of them, almost all, seem to say that if and when extraterrestrial life is encountered, it's not going to be a huge surprise to their faith tradition. It's not going to rock it, it's going to enrich it. And yet, so people seem to have this expectation that for people in general, it's going to transform, maybe change our worldview, change religions, change everything in drastic ways. But when you ask people specifically about themselves, if it's going to have that effect on their own beliefs, they seem to say, well, no, actually, I can't, it fits right into my faith tradition. So there's something sociological going on in there. And in fact, any of these major faith traditions, as have been mentioned, already have built in them the capacity, in fact, probably the welcoming of the idea that the universe is large and there are diverse beings, and it doesn't necessarily threaten that faith tradition. And then I mentioned more specifically that the Christian tradition, it really doesn't need to be a threat. There are, of course, unique things about each particular faith tradition. So for Christianity, it's the incarnation of God in human form, and that creates its own sort of questions when you talk about life beyond Earth. But every faith tradition has those very specific questions. But I kind of think in general, people will both be amazed and transformed if we discover life beyond Earth, but it also won't necessarily upset some of the basic frameworks of human belief. But Chris, I'd like to hear your perspectives on this as well.
I just add what you brought up was, the, as it were, the problem of the uniqueness of the Christ. And what I just suggested you consult is our wonderful speaker from last month, from December, Adelia. And she, when she started addressing that, I said, oh, that's fascinating. So she had a different theological tradition than the so Thomas Aquinas, and everything being very, unique, and there could only be one Christ. And that when you move away from that into the more Franciscan, which is her tradition, then there is room for what I call, God's surprises and God's creativity.
There is also something that's very helpful. Thank you, Chris. There's also something very, I think, moving about what astronomy itself is telling us these days, which is that we are, not just in some kind of philosophical sense, but in a very concrete sense, we are connected to the rest of the universe. The cells in our very bodies were produced in stars through the fusion process of stars and the expulsion of this material at the end of stars' existence as stars. And then those materials get caught up in future star systems and planetary systems, and even our bodies. We are truly made of dust and star stuff. And that would be true for alien life as well. And so we share the building blocks of our bodies. We would share with other creatures that may exist in the universe in a very measurable way through science. And so that kind of, I think, should feed into our understanding as well, in that alien life forms may behave differently, but we're all products of the universe, the same universe, and I think that's really cool. So there you go.
Yeah, very helpful. And let me ad lib a question here that Jennifer just prompted. So yes, there's a universal physics, if you will. We believe that we share the same fundamental physics with the entire cosmos. Does that put a constraint on what's possible biologically?
Sure.
So that there's something maybe not quite exactly the same, but largely the same in the constraint that physics puts on biological development. Simon Conway Morris has argued that kind of an approach. Others have suggested, well, maybe not so much. Life could be very different in other places. But how much does that common grounding in physics constrain what's possible biologically? And then the question really would be to extrapolate that further. If it constrains it significantly, how much does it constrain what happens in terms of the emergence of intelligence and spiritual and moral capacities? In some ways, we're going back to the beginning of the whole presentation, but if anybody wants to pick up on that particular notion of constraint from physics to biology.
Well, there's a number of people who've written that mutations in the human genome are more frequent if they are energy efficient. In other words, if they don't take a lot of energy, they are more likely to occur. Can I pick up on something about Christ, though? I mean, I'm just a practitioner. And that was, you can't have a co-author like Chris and not pick up a lot of stuff about Jesus. And so I learned that Jesus drew people into his network that weren't drawn in by other people, people who were poor, women, others. So to me, Christianity, if it grows from the original guy, who, in my view, as a social scientist has become a kind of revolutionary in my mind. I think that it's just drawing in one more group of people if an ETI happens to land. So I kind of go along with Jennifer's comments about, I don't think ETI appearing is going to shake everybody's foundation. I am concerned about safety. And so are a lot of other people.
Yeah, well, that you know, I had this question: what if the aliens are moral and benevolent, but they inadvertently carry a virus to the planet that wipes us all out? You know?
Maybe they should visit at the time of a pandemic like
It
now.
has
Yeah.
been,
The whole machinery of vaccine development is really getting. I want to tell everybody, Chris got his first shot this morning.
Excellent.
Yeah, bravo. And he's
Well,
fine.
let me pose another question. And
Could
we're
I
going
could
to
I
just-
actually say one quick thing about the previous question you asked,
Yeah.
which is about the biology of life. And I just want to say that astronomers right now are actually very keen at looking at the stars around which these planets have been discovered, because some of these stars are very volatile and they have lots of flaring and lots of events that basically would incinerate any life that's on a surrounding planet, or do it periodically. And we've needed billions of years of stability on planet Earth in order for advanced life to be able to thrive and grow. And so there is some physics involved, even looking at the stars, to know whether or not advanced life built on the same physical principles of biology that our life is could survive. But I just wanted to say that.
It's very
Yeah,
interesting.
if I may just interject again on the science, you know, a many years project of myself and you know, particularly one other colleague and then a couple of other colleagues has been monitoring the activity, as it's called, of stars like our sun, but in a very much younger stage of their lifetimes or evolution, typical of when life was beginning to start on Earth. And our question is, you know, were we just real fortunate with our sun being relatively quiet at that stage or not? What's the typical pattern? The typical pattern at the moment seems to be it's all over the place. So maybe we were fortunate in our sun.
Interesting.
Yeah. So Goldilocks, not as a statistical average, but as a very lucky hand to draw. A couple of questions have engaged in more speculation about the moral character of possible visitors. Well, really beginning with the moral character of what sort of reception humanity might mount. I mean, suppose there was something circling and maybe landing. Would we inevitably interpret it as threatening and shoot it down? On the other hand, I like this question very much from Steve. If advanced aliens are aware of our presence, how can they be altruistic? In other words, Steve is assuming they are altruistic. How can they be altruistic and yet not enlighten us on how to end disease, war, and biodiversity loss? In other words, not if they're altruistic, they would help us. Or would they? So again, let me take you right back to kind of the core of this. What sort of reception might humanity give if we had strong, obvious evidence circling over our heads that we're about to be visited, but we don't yet know what the intent of the visitors might be? What kind of reception would humanity give? But speculate with Steve about altruism from the visitors. What would their altruism require of them?
Chris?
All right, Chris.
Well, one that thing, first of all, Ron, if they were circling overhead, what would we do? Well, that is discussed well in Arrival. So go look at that, because obviously there's a huge military presence and reaction to that. So it's actually quite well done in that. And let's say the finger gets close to the button at one stage. So, and as for the altruism, or again, Jennifer's original question about, harm and not knowing it. Well, there we go. That, that's our limitation in knowledge. We can do that. And I suppose if, well, again, those people who gathered, those skiers who gathered in Switzerland this time last winter, if they knew the results of their gathering, maybe they wouldn't have gathered at all, and started in the pandemic. So, as usual, hindsight is 2020. So, yes. How about the amazing intelligence and perception, whatever, of our ET visitors? Yes, if they can communicate that to us and bring us benefits, sure, that's what to be open to. Again, so many sci-fi novels about that, and whether they're going to be overbearing or whether they're going to be cooperative with our human species, we don't know. But it's certainly there, and it's something we're consulting. Are they going to be, moral? Obviously, what Margaret and I were trying to present is that we see this, for them to come and appear, there has to be so much in common with their evolution. The Goldilocks, kind of region is pretty narrow, through which we've come to, our Homo sapiens species at the moment, and we think that's going to be pretty narrow and similar for ET. That's the thesis we're putting forward at the moment. So, hopefully, yes, they will benefit us, and perhaps we will benefit them. That happens. That's what the best encounters are, mutual.
Well, that was the analogy that there's a narrow path for the Goldilocks region around a star, but there's also a narrow path for development, it seems to us.
Right.
But that's just our opinion right now. I think that the knee-jerk militarism that we saw in Arrival was troubling. It was something, it was honestly, one of the main reasons I think we wrote this chapter, because you need somebody to get together and decide what you're going to do if somebody shows up. I mean, the future of our species may depend on it, and it will depend on some international cooperation. So I think we're going to hear more about this in the future. But I don't think it's going to be an easy road. We're going to have to come to some agreements.
Right. Well, earlier on, Jennifer, you said you had a question you were reserving for the final stage. We're already about 5 minutes past the stated time. We'll maybe extend for another 5 minutes, but Jennifer, go ahead with your question.
Okay, so I have a comment and a question. A comment is that, as one of the people in the Q&A pointed out, it is statistically unlikely that we are going to encounter an intelligent species visiting us. It's not impossible, but it's unlikely, and that's unfortunate. But given the vast size of space and the difficulties of advanced life evolving and traveling and all that. So our discussion has been interesting in the case they do arrive, but it's also, to me, more rich if we compare what we're talking about, how we respond to alien life and how they will behave with us, when we also compare it to the alien life that we already encounter here on our own planet. How do we treat other species. We know, for example, that elephants are very intelligent, social, and yet we subject them to poaching and killing for their tusks and things that harm them both socially and biologically. So, we can examine how we relate to other species on Earth as we imagine how we may relate for good or ill with species beyond Earth. And that's something we can apply to our lives even today. Okay, so the question that I want to ask Chris and Margaret are, how do we now, the people in this conversation thinking about this issue, how do we balance a sense of curiosity and wonder and awe regarding this possibility of encountering alien advanced life with a sense of wisdom and caution and appropriate fear? Where is that balance between, or what is the right balance between being nervous and afraid with being hopeful and excited and feeling, filled with curiosity and wonder? Can you speak to that balance?
Chris, you want to start?
If you like, but this is a question you ask. You're a scientist, and so I think you know the answer. That one searches for things in science because of the excitement of finding, and so one's open to the new and actually doesn't fear the new. And certainly as a person of faith, I don't fear the new. It's if it's part of creation, then I don't necessarily fear it. There's obviously things like COVID-19 that, yes, we do have to have a healthy fear of that. But so it's obviously an openness to the new with a caution as well. You talked about balance. Yes, we need that. And we need balance for everything, both on our Earth and beyond it.
Thank you.
So,
Well,
Margaret,
I can't top that. I can't top that. I think it was a really lovely answer from Chris. But I have to say that the more we looked into this question as relates to ETIs, I think they're going to be moral beings, because I think that intelligence maybe drags with it an efficiency of ethics. Ethics is an efficient way for people to deal with each other, a sense of right and wrong, in a structure of principles and concepts that guide people's behavior. I mean, it just makes sense that it would be hard to create a very, very intelligent species who was not benign at fundamental basis. Now, they may have their own agenda. They may have a star about to explode and need some place to park for a while. But I think that fundamentally an ETI, and I do believe this, will be beneficent, will be intelligent, will be a moral thinker. I don't think they'll necessarily be religious the way we are, because I think some other accidents happened in the evolutionary sequence to make us more probably religious thinkers than not. We'll put it that way. So I think that's it. But I like your answer, Chris. Be brave, be a scientist, don't be afraid of the new. I love that. That's great.
yes.
Well, thank
Yes.
you both. I just have to say that I've been very impressed by hearing from both of you, and your different perspectives, your different expertise really adds a richness to this kind of conversation. So thank you, Margaret and Chris and Ron, for allowing me to sit in on this.
Thank you, Jennifer. We're really very honored to have you.
Yes, thank you, Jennifer, so much for your work.
Your
Thank
own-
you, Margaret and Chris. We really have got to wrap it up. I appreciate your patience and letting this go a little bit over time. But anybody who's looked at the stars on a clear night has felt the wonder and the awe that Immanuel Kant witnessed in his own life. The extraordinary kind of taking off of the conceptual limits that come from us when we contemplate what might be out there. So thank you so much